Welcome back to Molecules Matter with Dr. Dan, the podcast where we explore the remarkable molecules that influence human health, one fascinating compound at a time. I'm Dr. Dan, an organic chemist, and every episode we take a deep dive into the science behind molecules found in nature, foods, supplements, or cutting-edge medical research. Today's topic has become one of the most popular supplements and foods in the brain health space. You'll see it in mushroom coffee. You'll see it in nootropic stacks. You'll see it in grocery stores. You'll see influencers claiming it sharpens focus, lifts mood, and even regrows nerve tissue. That mushroom is lion's mane, scientifically known as Hericium erinaceus. It gets its name from its shaggy, white, cascading spines, which really do resemble a lion's mane, or, if you prefer, an unfortunate pom-pom. But underneath that unusual appearance is a genuinely interesting chemistry story. Lion's mane produces two familiar molecules and their families found almost nowhere else in nature. These are hericenones and erinacines. Today, we'll talk about what these molecules are, how they interact with your nervous system, what the actual clinical evidence shows, and how to think about lion's mane if you are considering it. Let's dive in. What are hericenones and erinacines? Let's start with the chemistry because it's genuinely elegant. Hericenones are aromatic compounds found primarily in the fruiting body, the mushroom cap and spines you would actually see growing. Erinacines are diterpenoid compounds, specifically xanthine diterpenoids, found primarily in the mycelium, which is the root-like network the fungus uses to grow. So, depending on whether a supplement uses fruiting body, mycelium, or both, you're getting different concentrations of these two molecules and their families. Both hericenones and erinacines are relatively small and lipophilic, meaning fat-soluble molecules. That matters because size and fat solubility influence whether a molecule can cross a blood-brain barrier, which is the highly selective boundary that protects your brain from most substances circulating in the bloodstream. Researchers believe hericenones and erinacines are small and lipid-friendly enough to cross that barrier, which is a big part of why they've generated so much scientific interest. Let's talk about the NGF connection. Here's where things really get interesting. Both hericenones and erinacine compounds have been shown in laboratory studies to stimulate the biosynthesis of a protein called nerve growth factor, or NGF. NGF is exactly what it sounds like, a signaling protein that supports the growth, maintenance, and survival of neurons. Think of NGF as a kind of fertilizer for your nervous system. It helps neurons grow new connections, called neurites, and it helps existing neurons stay healthy and functional. In laboratory studies using mouse astroglial cells, researchers exposed cells to individual hericenones labeled C, D, E, and H and measured how much NGF the cells secreted into the surrounding culture medium. All four increased NGF secretion, with hericinone H producing the largest effect in that particular experiment. Erinacines have shown similar and, in several experiments, even stronger effects. To date, researchers have identified roughly 15 different erinacine compounds labeled erinacines A through K and later P through S. Several of them, including erinacines A, B, C, E, F, H, and I, have been identified as potent stimulators of NGF synthesis, both in cell cultures and in living animals. Why does this matter? Because NGF doesn't cross the blood-brain barrier well on its own. You simply can't take an NGF supplement and expect it to reach your brain. But if a molecule can cross that barrier and then stimulate your own cells to produce more NGF locally, that's a much more elegant biological strategy. That's the central hypothesis behind why lion's mane has captured so much scientific attention. Let's talk about beyond NGF and other proposed mechanisms of lion's mane. Because NGF stimulation isn't the whole story. Researchers have also investigated erinacines for other potential mechanisms, including, number one, reducing amyloid-beta plaque accumulation in animal models, amyloid-beta being a protein fragment closely associated with Alzheimer's disease pathology. Number 2, increasing expression of an enzyme called insulin-degrading enzyme, which, among other functions, helps break down amyloid-beta. 3, reducing markers of neuroinflammation in animal studies. 4, supporting nerve regeneration after injury in animal models, including studies on peripheral nerve damage. Some specific erinacines, like erinacine E, have been studied for potential effects on neuropathic pain in rodent models. Again, I want to be careful here. Most of this mechanistic work has been done in cell cultures and in rodents, not in large human trials. But the underlying biology is genuinely compelling and similar in humans, and it's part of why lion's mane has moved from folk remedy to a legitimate subject of neuroscience research. So what does the human research actually show? This is a question I always come back to, because laboratory promise and human clinical evidence are two very different things. Let's go through what we actually have, and let's first talk about mild cognitive impairment. One of the more frequently cited studies is a Japanese double-blind, placebo-controlled trial in adults aged 50 to 80 with mild cognitive impairment. Participants took lion's mane, referred to in the study by its Japanese name as Yambu-shiitake, for 16 weeks. The treatment group showed improved scores on a cognitive functional scale compared to placebo during the treatment period. However, when supplementation stopped, those cognitive benefits diminished over the following weeks. That detail matters. It suggests any benefit may depend on continued use, rather than representing a permanent structural change. And so with lion's mane, if you're going to take it, you should expect to take it for long periods of time. Let's talk about lion's mane and Alzheimer's disease. A separate small clinical trial examined lion's mane in patients with diagnosed Alzheimer's disease over 49 weeks. Researchers reported improvements in activities of daily living. However, there were no statistically significant improvements in cognitive test scores compared to the placebo group. So the picture here is mixed, not a clear win. Let's talk about lion's mane in healthy younger adults. More recent research has looked at healthy adults rather than those with existing cognitive decline. One randomized placebo-controlled study gave healthy adults aged 18 to 45 a single 1.8 gram dose of Hericium erinaceus extract. Researchers found participants performed a cognitive task called the Stroop test more quickly, about 60 minutes after dosing compared to placebo. But a separate, similarly designed trial looking at both acute and chronic effects on cognition and mood in young adults produced results the researchers themselves described as inconclusive. And a lot of times in a scientific paper, we need to understand why researchers say inconclusive is not because the results aren't valid. It's not because the results aren't powerful or useful. A lot of times it's because they say this so that they can continue to get funding from the government agency or whatever grant they're getting the money from to continue to do their research. If they said, this is the result, it's great, and all is said and done, then they wouldn't be able to get more money. So just something to understand when you read a clinical study, a paper. Let's now talk about lion's mane and mood, stress, and sleep. There's also research outside the pure cognition space. An older Japanese study gave adult women lion's mane containing cookies daily for 4 weeks and tracked self-reported symptoms of irritability, anxiety, and heart palpitations. Those symptom scores improved in the treatment group, but not in the placebo group. A more recent trial reported improvements in self-reported depression, anxiety, and sleep quality scores after 8 weeks of supplementation compared to baseline measurements. These are promising signals, but many of these studies are small, short in duration, and rely heavily on self-reported symptom scales rather than objective biological markers. Let's talk about lion's mane and gut and immune health. Separately from the nervous system story, lion's mane has also been studied for gut and immune effects. Animal research suggests certain polysaccharide compounds in lion's mane may support beneficial gut bacteria, functioning somewhat like a prebiotic. So isn't that interesting? When you take lion's mane, either when you cook it yourself or you take a supplement, you are getting prebiotic type activities. Researchers have also described lion's mane extracts as having immunomodulatory, antioxidant, and anti-inflammatory properties in preclinical models. This is a helpful reminder that hericenones and erinacines are not only the interesting molecules in this mushroom, but they are the most closely tied to its reputation for supporting the brain and the nervous system. So, where does that leave us? Here's my honest assessment as a chemist looking at the scientific literature. The mechanistic and preclinical science is genuinely compelling. Hericenones and erinacines are real, well-characterized molecules with a documented ability to stimulate NGF production in laboratory and animal models. That's not hype. That's published, peer-reviewed chemistry. But the human clinical picture remains early and mixed. Some trials show modest cognitive or mood benefits. Others show no significant difference from placebo. Sample sizes tend to be small, trial durations tend to be short, and benefits observed during supplementation sometimes fade once supplementation stops. That pattern, promising mechanism, inconsistent human outcomes, is extremely common in nutritional neuroscience, and it's exactly why I always encourage healthy skepticism rather than either blind enthusiasm or blind dismissal. For myself, when I use lion's mane, I use it for cooking. I put it in my soups, in my ramens, and I also saute it with butter, salt, and pepper and eat it with other foods. I feel the benefit. I do feel like my brain is sharper, it's more active. I do feel like the neurons are coming together in a more organized fashion. Let's talk about safety considerations of lion's mane. From a safety standpoint, dietary use of lion's mane is generally considered safe for most healthy adults. Reported side effects in clinical studies have been relatively mild and infrequent, including occasional abdominal discomfort, nausea, or skin rash. People with known mushroom allergies should obviously avoid lion's mane. There's also some theoretical concern regarding interactions with blood-thinning medications. So if you're taking anticoagulants, this is worth discussing with your physician before adding any mushroom supplement. As with any supplement, quality and sourcing matter because hericenones concentrate in the fruiting body and erinacines concentrate in the mycelium. Products vary considerably depending on which part of the organism and which extraction method was used. That variability makes it genuinely difficult to compare results across different studies and different commercial products. So let's talk about practical takeaways. If you're curious about lion's mane, here's how I'd think about it practically. This is not a substitute for treatment of diagnosed cognitive impairment or a mental health condition. The clinical evidence simply isn't strong or consistent enough to support that kind of claim. If you are a generally healthy adult interested in trying it for general nervous system support, the safety profile appears reasonable and the underlying molecular biology is scientifically interesting. Look for products that specify their hericenone and erinacine content, or at minimum, specify whether the extract comes from the fruiting body, mycelium, or both, since that tells you which molecule family you're likely getting more of. Lion's mane is wonderful to eat as a whole fungus and has started to show up on grocery store shelves. Eat 1/2 of a cup of cooked lion's mane twice a week. And like I said earlier, I like to saute it in butter until soft or add it to my ramens or curries as a meat substitute. And as always, temper your expectations. This is an area of active ongoing research, not a settled clinical conclusion. And this is something personally in my research group that I'm studying a lot, the molecular composition of lion's mane. Now let's go to some final thoughts. What draws me to lion's mane as a chemist isn't the marketing. It's the elegance of the underlying biology. Here you have a mushroom producing two entirely distinct families of molecules in two different parts of its structure, both converging on the same biological target, which is nerve growth factor. That kind of layered chemistry doesn't happen by accident, and it's part of what makes fungi such a rich, unexplored source of bioactive compounds. Whether that biology ultimately translates into a meaningful, reliable clinical benefit for humans is still being worked out. And that's exactly the kind of honest, evolving science I want this podcast to reflect. Thank you so much for joining me on another episode of Molecules Matter with Dr. Dan. If you enjoyed today's episode, I'd appreciate it if you would subscribe, leave a review, and share this episode with someone who's curious about the science behind mushrooms and brain health. Remember, every molecule tells a story. The more we understand those stories, the better equipped we are to make decisions that support our health. Until next time, stay curious and remember, molecules matter.